Thank you for joining us again in our sizing software series. In this video, we are going to be talking about the sizing results page of the Tolomatic sizing software. This is the 5th page in the sizing software, and it shows the results that the sizing software will produce based upon the specifications inputted into the motion profiler page and product selector page specifically. On the sizing results page, the very first thing it shows you is the results of every actuator combination that the sizing software was able to pass. In this example, we have several RSA 50 and RSA 32 actuators that passed in the sizing. The way the actuators are oriented in this page is from a price factor from lowest to highest. So typically the most cost-effective solutions on the top and least cost-effective solution on the bottom. Also displayed are the different types of models, screw belt combinations, the reduction type. This could be LMI for inline motor mount, or RP1 or RP2 for reverse parallel 1-to-1 ratio or reverse parallel 2-to-1 ratio. It has the ratios here. If a Tolomatic motor was chosen, it would display underneath the motors column, the price factor, and then the configuration string for that basic actuator. Each of these columns can be organized by clicking the up and down arrows to organize it based upon reduction, screw belt type, or price factor. You can also filter through models by clicking on the filters up at top. You can either do filters through models, screw type, reduction type, and motor type if you have a Tolomatic motor selected. These filters can be very helpful when you have hundreds of solutions and just trying to narrow it down to 1 or 2 actuators. On the bottom of the results page, there are specifications that you can access for each type of actuator. To access these, you click on an actuator, and below you'll notice that these buttons light up. These buttons allow you to see the motor specifications, the screw/belt critical speed, or the force. Within the motor specifications, if a non-Tolomatic motor is selected, this shows what motor specifications will be needed for the third-party motor or gearbox mounting into the actuator. These are input parameters into the actuator, so if you have a motor and gearbox, these would be the parameters for the gearbox output as opposed to the motor's output. As you can see with this application, we have a very low RPM, and there's a peak and RMS speed, along with a peak and RMS torque. It's important to note these values when trying to size out a motor. With the critical speed, this shows how fast the actuator is capable of going and how fast you are currently moving in your application. This is important when you're operating within fast applications and to see if the actuator is near its critical speed value. Screw/belt force, this shows the maximum force of the actuator along with the forces you are operating at. One handy thing within this screw/belt force tab is the estimated life of the actuator. For all ball nut and roller screw actuators, we are able to estimate the life of the actuator, and this is very helpful when you are trying to figure out if the actuator is going to be a long life solution for your application. With this particular actuator, we were able to do 19 million cycles. But if you notice, if I choose a different actuator and click on the same one, the life estimate changes. And this life estimate is based upon the dynamic life rating of the screw itself. If you arrive at the sizing results page and the sizing results show no matching products, or you do not see the actuator that you wish to use for your application here, most likely there's a reason for that actuator not passing within the sizing software, and you can find those actuators that did not pass underneath the non-matching products tab. This tab shows all the actuators that were sized and all the ones that did not pass the sizing. So if you're looking for a reason why the actuator did not work in this application, then you can simply click on the actuator and click on the Why Failed button. This button will show you the reason why the actuator did not work in this application. As you can see with this one, the maximum thrust rating of the application was above the maximum thrust rating of the screw itself. And that is the reason why this actuator did not pass. When trying to size roller nuts for an application within an RSA actuator or an IMA actuator, oftentimes you will find that they won't pass the sizing software. One reason for this could be that the roller nut has reached the thermal limit due to the force and speed constraints of the application without enough dwell time. In this example, we're showing an RSA 32 with a roller nut that did not pass. And if you click on the Y failed, it will show you that the thermal limit of the screw has been reached and that additional dwell time is needed for the application. This is often the case when working with high force and high speed applications where you're trying to use roller nuts. In situations like this, it is recommended to add extra dwell time to the motion profiler and then attempt to get the actuator to pass in the sizing results. When sizing an IMA, it is important to look at the motor specifications for the actuator itself, whereas these will pertain to the peak and continuous force rating for that actuator. With this application is showing you the continuous force rating and peak force rating for the IMA 44. And now you'll notice that the peak force rating is well below the margin for peak, and the continuous force rating is well below the continuous force. If either of these are very near to the top of the line, then it might be a good idea to size up to a different actuator size or look at switching screws or nuts in order to reduce the torque or reduce the speed of the application. When sizing rodless actuators for an application, an additional feature at the bottom pops up, and that is the moment and load button. So you can use this to look at the moment and loads capability of the actuator itself and the moment and loads that the application will be seeing. As you can see here in this example, we are operating at a 200-pound load, and the maximum load capacity of that actuator is 225 pounds load. For in this example, we'd most likely look at sizing up to a different actuator or switching models in order to have a larger margin between these two. On the sizing results page, the project units will determine which project units are used in the motor specifications, speed, and force buttons on the bottom. So for example, if you were to look at the motor specifications with English units on, you would receive inch-pounds for your torque requirements for that motor. But with the metric project units, those same torque requirements will be in Newton meters. This is the same with the force specifications and the critical speed requirements. If you have any additional questions about the sizing software process, feel free to reach out to your local Tolomatic applications engineer using the number on the screen or the web address.